Hello, my name is Clint Arnett. I'm a training coordinator with the Texas A&M Engineering Extension Service at our training facility in Disaster City. The Texas A&M Engineering Extension Service is a state agency under the Texas A&M University system. The Texas A&M University system includes 12 universities and 7 state agencies. Texas A&M Engineering Extension Service, or TEEX, is one of the state agencies. Among the things that TEEX does is workforce training, which includes economic and workforce development, such as economic development, therapeutics, manufacturing assistance, market intelligence, product development and testing. There's another division that does fire and rescue training. That's the division that I work for. We do industrial and municipal firefighting, rescue training, hazardous materials training, emergency medical services training, various technical assistance projects, incident management, leadership, and we have a fire recruit academy. We also do Homeland Security training. That includes Department of Homeland Security and FEMA funded training in health and medical, public works, infrastructure protection, executive programs, and we're a member of the National Domestic Preparedness Consortium. We're also a member of the National Cybersecurity Preparedness Consortium. We have a division also that does law enforcement and security training. That includes crime scene investigation, corrections, explosives training, accident reconstruction, defensive tactics, emergency driving, basic police academy, forensics training, threat and risk assessments, and we have a police academy on site. We have a division that does infrastructure and safety training. That includes water and wastewater and environmental training, safety and health, transportation training, electric power, heavy equipment, telecommunications, and OSHA confined space training. We have a division that does disaster response and recovery. That's our Texas Task Force 1 division. Texas Task Force 1 is one of the 27 FEMA urban search and rescue teams and is also a state asset within the state of Texas. The TEEX facilities that I'm going to talk about today are the Brayton Fire Training Field, Disaster City, and the Emergency Operations Training Center. The Brayton Fire Training Field is the largest live-fueled firefighter training facility in the world. It's located on the same site as Disaster City and includes numerous props with live fire training. Disaster City was built beginning in 1997 as a training ground for Texas Task Force 1. Since that time, it's been used for training emergency response professionals from all over the United States and throughout the world. Some of the courses that we train in the rescue program are rope rescue, confined space rescue, trench rescue, hazardous materials, search, structural collapse rescue, rail rescue, and swift water rescue. We have numerous props in Disaster City and on our rescue campus to facilitate this type of training. The first is the Technical Skills Training Area. This is designed to teach the kind of skills that emergency responders would need, that urban search and rescue emergency responders would need if they were responding to a large structural collapse incident. In these incidents, many times it's hours or days before additional resources are available, and we're training the responders that would assist the local authorities who might be overwhelmed or need additional capability and equipment. So there's 3 basic areas that we train at the Technical Skills Training Area. That's lifting and moving, breaching and breaking, and shoring. Lifting and moving is the idea that it might be some time before heavy equipment is available to move debris and to try to access people who might be trapped. So we teach responders how to use the tools that they might have on their rescue truck or on their apparatus, or that they might be able to source locally in order to move these heavy objects. These techniques include using levers and rollers and simple machines to move heavy objects, learning how to calculate the weight and the center of gravity of various objects, how to rig them for handling by crane or by other heavy equipment once heavy equipment does arrive. The students learn to move very heavy objects using basic hand tools and support them safely. Next is breaching and breaking. Breaching and breaking is the idea that we might have to cut through steel or concrete or something in order to access someone who might be trapped. There's a lot of tools and equipment that are used for this. This would include saws, drills, hammers, and hand tools. And all of these tools are powered by electricity, hydraulic power, pneumatic power, or gasoline power. The tool selection and the technique selection is based on the incident itself. So, for example, if we had a victim trapped inside a confined space and they were right on the other side of the wall that we needed to cut through, we'd have to use a special technique so that all the spoil from that cut would end up on our side of the wall. If the victim, on the other hand, is back a ways or in a safe area, we determine that it's clear to move in there, then we can use faster methods to get through that area to access them. We have tools that are, again, powered by various things, and that's driven by whether we have water in the location or whether there's a hazardous atmosphere or whether we can generate sparks. There's a lot of different factors taken into consideration in how we determine which tool and which technique we use. Next is shoring. Shoring is the idea that a structure might be heavily damaged, but we may need to be able to go inside to look for people or to try to rescue people. We may want to use a shoring system to brace the building such that it's safer for the responders to enter. These systems are built largely of wood, and we know that a lot of engineering work has been done on this such that we know that if we use certain species of lumber with certain size nails and erect it in certain ways, we have a very good idea of what those shoring systems will support. There's also commercially available shoring systems made of steel and aluminum and so forth that can be erected very quickly, and those are great to get the responders working while they're arranging for delivery of lumber and nails and other hardware and so forth. So after we leave the technical skills training area, we move into Disaster City itself. Disaster City has numerous props replicating the type of infrastructure that you would find in a typical community. So what grips you immediately is that we have a large passenger train derailment. It has 6 rail coaches and a locomotive. The rail cars are derailed in a very realistic fashion, and the different cars represent different types of cars typical in a passenger rail arrangement. So there's coach type cars, there's sleeping cars, there's a buffet and dining car, and so all of these are laid out very realistically. We use this to teach a passenger rail rescue course. We also teach use it as part of our numerous exercises that we do. Adjacent to Disaster City, we have a hazardous materials train derailment as well. And so this features numerous rail carriages that would carry different types of hazardous materials. So there's box cars, tanker cars, hopper cars, etc., all of which the responders learn how to identify by looking at the car what type of material would likely be carried on it, also how to work with the various markings on the car to determine what would be in it. And then they learn the techniques with how to respond to it, how to reconnoiter the situation, how to determine where the leaks are, how to contain the spill, etc. So these cars are also plumbed where we can make them leak. Some of them leak on demand, so we can have a very realistic flow of simulated product coming from the cars, which works very well for some of our scientific research efforts that I'll talk about in a few minutes. Here's another image of our hazmat train derailment showing some of the other type cars. So among the other buildings in Disaster City, we have one that simulates a single family residence. So this is a residence or a home where people would live. So typically inside it has furniture that would be typical of a residence. So it has beds and couches and interior furniture. It has a basement with 2 rooms underground, and it has different types of roof collapse in different sections of the building. So a very realistic prop. Next we have our House of Pancakes, which represents a small office type building. It's called the House of Pancakes because it has a pancake floor collapse at the back of it. You can see it in this photo. There's 3 levels of pancake collapse in the center, and that's where the walls have failed, causing the ceilings and floors to stack up on top of one another. This is typical of the type of damage that you saw perhaps in some of the photographs from the Haiti earthquake, where they had a lot of this type of collapse. So there's voids in between each of these levels, which sometimes are survivable and victims can be found in there. So in our pancake collapse, the students will have to size up the building. They'll have to erect their shoring system in a typical evolution. They'll have to breach through an exterior wall to get into the pancaked area. They'll have to search each level and shore each level to support it. Then they'll have to break through another concrete panel into the next level, and then they'll have to search and shore that. And as you can see, there's multiple levels for them to have to work through. This is a very challenging exercise, but also very realistic for many types of disasters. This section of this building is now enclosed in steel walls, which make it dark inside, which add realism and difficulty to the project. Across the street from the House of Pancakes is the strip mall. The strip mall is a shopping center, typical of what you would find in many communities. So there's 5 stores, and each one features a different type of roof collapse. What's great about this prop is that it's reconfigurable. There's a lot of different ways that we can move and reconfigure the ceilings in each of the stores for different types of training. We can change up the storefront facades, we can remove the railings, we can add debris as you see in this photo or take it away, all depending on what the training objective is for the class or the particular exercise that we're doing. Next is our theater building. So this is a theater, auditorium, multi-use complex. Inside it has a lobby in the front. Inside there's a sloped floor, and we have seating in it just like a theater auditorium, and there's a stage. However, we can remove the seating if need be, and we have done so for various events where we've created large mazes for robots. We've done all sorts of different things with this building. On the side of the building, there are 3 more rooms, each of which has a different type of ceiling collapse again. So we use this building also for our advanced shoring classes, where the students would have to erect very large shores to support the exterior walls or even the interior walls. And they've built some very large interior shores to support the ceiling in the large open room inside. Next is our government complex building. This is a multi-story steel and concrete structure. This building is designed to simulate disasters such as the Oklahoma City Murrah building, or the Kobar Towers in Malaysia, where you have a large high-rise building, an entire side of the building has collapsed, creating a rubble pile out on that side. So that's what's going on the side of the building that we're looking at in this image. This is the side that's collapsed, creating the rubble in the foreground. We have a lot of other realistic challenges in this building. On the second story, you can see there's a large hanging slab, and that's designed to simulate hanging debris as you might find at one of these disasters. For example, at the Oklahoma City Murrah building in 1995, there was a lot of large hanging debris. There was a huge slab hanging that had to be first restrained and then later removed. One of the responders at the scene, in fact, was killed by falling debris, so this is a very serious concern to the emergency responders. Inside the building, this is the most realistic of our Disaster City props in that there's actual suspended ceiling, HVAC ducting, electrical conduits, and sheetrock interior walls, simulating the inside of an office building. It's intended to be like a government complex or a large office building. But this is very typical of the kinds of debris and entanglement hazards that you have in a real disaster. On the other side of the building, we have large concrete columns which are designed to simulate the concrete columns at the Pentagon at the 9/11 incident, where large concrete columns had failed, exposing the reinforcing bar structure inside. So we've included that in this particular prop. There's also some various tunnel and void spaces in the rubble pile out behind it. I'll talk more about that in a moment. And here's an image from the end where our advanced breaching and breaking class is cutting some steel on the exterior of the building, and they're doing so by hanging from ropes. This is a very difficult technical challenge for some of the urban search and rescue responders. Next is the professional building. So the buildings you've seen up to this point are all concrete, and a lot of the damage is typical of what you'd find at earthquake or explosion type disasters. Next is our professional building, and this is a wood frame structure, and then there's a wooden debris pile next to it. So this is typical of some disasters, including one we had in Texas just a couple of years ago, where a large explosion ripped a whole part of a building, a wood frame structure like this apart. So there's some particular structural challenges for the responders that are working on an incident like this. And in this case, we have the challenge of needing to search the upper story of this safely, frequently done by canines or by other means. But there's a lot of different ways that we can run this scenario to test the responders. Disaster City features 3 rubble piles, and these are very important for some of the search training that we do. The rubble pile you see here is our rubble pile 1. This is a concrete rubble pile, and it's used largely for search training, either canine search training or technical search training. For the technical search, we have systems like cameras on poles. We have listening devices that can pick up the lightest tap or scratch that a survivor might make inside the pile. We can use those sounds to triangulate their position. On the canine search side, our dogs are trained to find live human scent. So this has voids placed throughout the pile where we can safely put volunteer victims that hide there in the pile for the canines to search for them. This is critical for the dogs to learn their task and to be effective at finding victims in this type of structure. Also, this pile features an engineered tunnel system underneath, consisting of various sizes of concrete culverts with junctions, vaults, and so forth interconnected. This is a great prop for simulating public works infrastructure, like sewers and utility chases and so forth, and very realistic for some types of training and some of the exercises that we do. The next is adjacent to our wood frame structure that we talked about a moment ago. We have a wooden debris pile. And so a lot of our tornado and hurricane type disasters, you have a lot of wood frame structures and homes that are damaged, and you have these large, very large piles of wooden debris that our canines have to be able to work in. So it's very important to have this type of structure for the dog teams to be able to work. And then next we have our rubble pile 2, which is the largest rubble pile. This is next to the government complex building, and we just rebuilt this one this past year and added additional hallways and void spaces underneath it, in addition to some of the natural voids throughout the complex. So this is a great challenging project. This rubble pile consists of concrete and steel. So for our FEMA canine training requirement, you have to have multiple rubble piles of different type of structures. So the first rubble pile we talked about is concrete, and the second one we talked about is wood, and then this one is concrete and steel. So different types of structure. So among the training courses that we do in Disaster City itself are structural collapse rescue. So this image shows some structural collapse responders in a real incident, and they've packaged a patient and they're having to use a complex technical rescue rope system in order to evacuate the victim that they've rescued from this section. Next, we do shoring. We talked earlier about the wooden shoring structures. There's interior shoring that you would erect inside a building, and there's exterior shoring that you would erect to support the exterior walls of a building. So this image shows a complex interior shoring system being constructed by students in one of our advanced shoring classes. They're using to support some ceilings that have pancaked on top of one another. We also talked about advanced breaching and braking earlier. So the advanced breaching and braking uses the techniques of breaching and braking that we talked about in TSTA. However, now we're going to do them off of ropes and at height. So the students are having to work high in the air, and they're having to work while hanging from ropes, whether cutting with torches or saws or jackhammers or what have you. So that adds a huge dimension of complexity to the rescue operations. Next is rescue in a contaminated environment. So at many disasters, whether man-made or natural, you can have toxic chemicals that might be spilled that would require the responders working in the area to wear additional levels of personal protective equipment that might include breathing apparatus and protective suits. So we teach rescue in contaminated environment, which is teaching some of these heavy rescue techniques and trying to perform them with the additional challenge of doing it so in the proper protective equipment. This also means that you have to be prepared to decontaminate these people when they come out of the operational area. And so there's a whole great deal that goes with this. So next so beyond the training that we do, a big part of what we do in Disaster City is exercises. So we've done multiple exercise scenarios. Normally we work with the jurisdiction that's going to be training and determine what their objectives for the exercise are going to be. So these could include fire departments, these could include military organizations, urban search and rescue teams, and others. So some of the exercises that we've done in Disaster City include a major hurricane, a major earthquake, improvised explosive devices, improvised nuclear devices, radiological dispersal devices, toxic industrial chemicals, chlorine tank explosion, and pandemic influenza. We've also done an international exercise, and we frequently do exercises including international participants. So the international exercise we did several years ago, we invited search and rescue teams from all over the world to come participate in a single exercise. And just as they would have to at a large international event, whether it be a hurricane or, again, the example of the earthquake in Haiti, these responders would have to work together and overcome the language barriers and solve the logistical problems of using their various different types of equipment and so forth together. And so for our exercise, we set them up in a common command structure for all of the teams to work under, and then we gave them taskings just as they would have in a real incident to work through. So we do custom designed exercises where a jurisdiction may have a particular challenge that they want to exercise their team regarding. So in this photo, for example, we have a military organization that is wanting to perform rescue operations in a contaminated environment. So they want to exercise, put their participants through using all of their actual equipment as they would on a real incident, and have to work through all of the challenges with that to rescue people, to decontaminate them, to provide medical treatment. For some of these exercises, we've had large groups and we've provided a base camp facility for them, so that they would have to set up in austere conditions and in a base camp at another designated location. In this case, we did it at the Texas A&M Riverside campus, which is about 10 miles from Disaster City. This is a good distance for this because it gives it stretches the logistics of the organization that's exercising, in that they've got to transport their gear and their personnel 10 miles to the operational area. So if they if they forget something, or if they, it also stretches their communications. And so they have to work through those challenges. But it's not so far away that they don't really get any training done if they make one of these mistakes or have one of these learning opportunities. We've done numerous exercises for our National Guard teams within the United States. So these are a military organization that responds to civil disasters within the United States. And so one of their missions would be at a large incident requiring decontamination of the public, that they would help provide those decontamination services for the people affected. So they have numerous different organizations that respond in different ways to these type of incidents. So, and these photos show some of the National Guard personnel responding in simulated exercises throughout Disaster City. So here's an aerial view of a very large exercise that had nearly 600 personnel involved. And so you can see in the center of the image, there's decontamination lines set up, which are taking the responders and the victims that are responding at the top left of the image. They're coming out of the operational area and having to be decontaminated. And then when they come out of decontamination, they go through the medical tents that are set up beyond that and further get treatment. So this is a very realistic type scenario here, and typical of how this type of incident would have to be run. So we've also done some nuclear exercises in Disaster City, which in coordination with the Nuclear Engineering Department and the Nuclear Security Science and Policy Institute. They've brought visitors out that we've been able to place live radiological sources in Disaster City, and then manage the students as they locate the sources, determine what the safe areas around them are, and determine what the types of sources are. We've also done these kind of exercises using personnel from the NSSPI to facilitate exercises that we've done for professional responders, including some of the urban search and rescue task forces. This is a great capability that's not found in a lot of places. Another thing that we bring to some of these exercises is role players. So we arrange for volunteers from the community to come out and play various roles in these exercises to add realism for the organizations that are training. So these personnel could role play either victims, or they might be government officials or company officials that would be that the responders would have to interface with. In this case, there's military responders having to work with some civilian role players operating. We have moulage artists that can do moulage simulated injury makeup. And these are some examples of the type of makeup they do. This adds a tremendous amount of realism to the exercises for the responders that are training in them. Among other things we've done beyond the training and the exercises, Disaster City has been used for some scientific research and product development efforts. Notably, we've worked with our National Institute of Standards and Technology, and we've facilitated numerous response robot evaluation exercises over the years. The purpose of these was to develop standard test methods for robots that might be used for emergency response. So there's no one single robot that can do everything in a disaster. So the different challenges you might have in your disaster, this gives you a way of determining what capabilities you need, and then selecting a robot system that might have capabilities that are proven and measured for that particular challenge. In this case, it would be aerial robots. However, there's various ground robots as well. So in the aerial robots, that might be station keeping, that might be visual acuity. On the ground robots, it might be towing and hauling, manipulation, again, visual acuity and inspection tasks, grasping and removal tasks, recon, carrying sensors for hazardous materials. So that gives us an opportunity to recon a potentially dangerous area without having to put humans at risk in personal protective equipment, without someone having to put on a suit to go respond, at least initially, to the incident. Also on the same facility as the Brayton Fire Training Field in Disaster City is our Emergency Operations Training Center, or EOTC. The EOTC is a 32,000 square foot building. It includes 2 simulation-enabled classrooms with breakout rooms, 3 classrooms, and a public information broadcast room and multiple meeting rooms. The EOTC can be configured as an incident command post or an emergency operations center for full-scale and functional exercises held on campus. It's also possible to configure it as an emergency operations center or incident command post for simultaneous deliveries. So there's actually 2 large exercise rooms where we can do 2 of these large exercises at the same time. We can also use it to monitor and control field exercises being done in Disaster City. So while the emergency managers are working inside in the EOTC, the operational fire and police or military folks are working in Disaster City, and we can connect all of that together. We use a computer-supported simulation to create scalable, scenario-driven training. This can be used for direct delivery of simulation-based courses or can be used for exercise support. Our instructors and controllers have tremendous command and management experience, and we use a high instructor-to-student ratio so that they get a lot of individual attention for the students, a lot of coaching and mentoring for the students that are working in these programs. The Emergency Management Exercise System, or EMES, is the computer system that we use for running these simulations. And it can support local, jurisdictional, and regional large-scale response training and exercise operations involving role players and computer-injected events. So in these images that you see, the people at the top are role players that are responding to what the students in the exercise rooms are doing. So when the students in the exercise room call for the fire department or the public works or whatever, they pick up their phone and call, or they send an email or pick up their radio, they get one of the role players that you see in this image, who is a real firefighter or public works person or former city manager. These are the types of people that work as the people in that cell. And so they'll interface with them, and then the simulation records what they do and how that's delivered. So the exercise, and then the role players work together to pace the exercise as the students go. So the main class we do here is the Management 314 Enhanced All Hazards Incident Management Unified Command course. And this course focuses on incident management skills, staff responsibilities, and the related situational awareness and decision-making skills. However, we've done this type of course for various jurisdictions, and this would include major airports, transportation infrastructure sites, and others. We can do customized training for incident command post courses, emergency operations center courses, multi-agency coordination center courses, and departmental operations center courses. So that's the overview of Disaster City, the Brayton Fire Field, and the Emergency Operations Training Center. Thank you.